Alright, hell yeah. So this video shows that AI is quite often wrong, especially when doing unit conversions. And so what we have here is the density of aerogel. Why I brought this up is because water we all know is a density of 1, but then you have to say like 1 what? It's 1 gram per centimeter cubed. So then maybe I want to, and then in first chapter of physics, it's kind of cool to be like, well, hey, what has a density of 10? And then go the other direction, what has a density of 0.1? Like a close thing that has a density of 10 would be like steel. I know it's only like 7.5, 7.7, but hell yeah, that's close enough to 10. The next thing is like, what has a density of 100? Well, I don't know. I did look up that the center of the sun has a density of 150, so close enough. It's close enough to 100 than it is to the next unit jump to 1,000. And going this way, what has a density of 0.1? I wasn't, shoot, I'm sure I looked up something. Maybe just any foam. Maybe a foam has a density of just 1/10 of water. You know, I mean, foam is still heavy, but it definitely floats, and it floats really well. Like wood is like 0.5 sometimes. But anyway, and then I saw that aerogel had a density of 0.01. You know what I mean? So it's going to be 100 times. So this is 100 times. This is 10x lighter than water. And then I just recall, just from my studies with science, is that air is 1,000 times lighter than water. And then so we're going to get this in a second. And then I also found out that helium is almost, so air is 0.001. But then I found that helium and hydrogen, both those are very close to 10,000 times less dense than water. So that's going to be 0.0001. And so, but they're saying aerogel, I guess, can be as light as air. And I found that very cool. The stuff that I saw online was closer to 0.01, not 1/100,000ths, but just a hundredth of a gram per centimeter. Okay, so hell yeah. So now we're gonna fact check. All right, hell yeah. So now we're gonna fact check, but we need to figure out. We need to, like, what I want to know is 1 meter. So we're going to take a cubic meter. So this is 1 meter by 1 meter by 1 meter. And now this also, we do this with water. Water is 1 gram per centimeter, but how much does it weigh per 1 meter cubed? Well, this is also a good one to know. It's going to be 1,000 kilograms. There's going to be 2.2 pounds per kilogram. So this is going to be 2,200 pounds. And this is what we call a metric ton. American ton is 2,000, but this 2,200, that's where it comes from. And it's really accurate to be like 2,205 or 2,204.6. You know what I mean? Blah, blah, blah. If you want to get the accurate conversion between kilograms and pounds. All right, but booyah. So that's water. It weighs 1,000 kilograms. Now, what did we say that air was? Well, air was going to be 1,000ths. It's 1,000 times less. Did I even write that? Yeah, 1,000 times less. So if it's, what's 1,000 times less of 1,000? That's just going to be 1 kilogram, which is astounding that 1 meter of air, you know what I mean, if you encapsulated that and then took it into outer space, it would have a mass of 1 kilogram. I don't know. And then you put it on a different planet, you know what I mean, it would weigh that much. You know, put it on a scale or something. You do whatever you want with it. Anyway, so that 1 kilogram of air, or no, 1 meter cubed of air weighs 1 kilogram. So, so that's pretty cool with air. And so now we can start to, and that's going to be 1,000 grams. So 1,000 grams of air is 1 meter cubed. So they're saying that, see, right off the bat, we already know something about air that is just makes this just really stand out-ish. They're saying 1 cubic meter, a cubic meter of this aerogel would weigh between 1 gram and 500 grams. Well, that means it's hella lighter than air. That would mean it's 1,000 times lighter than air to half 1 time lighter than air, or however that goes. So that's the first thing that jumped out at me, that this is just a glaring error. And this happens all the time with AI, especially with units. So you definitely just have to be on your game. So, and we're doing first chapter physics stuff. And I swear, like, the whole factor label method is, it's worth spending some time on. So let's go do that. All right, booyah. So we're going to assume that these densities are right. You know what I mean? And yeah, it's as light as air, or it's not so light. It's almost, aerogel can be either light as air or about as heavy as water. That's basically what this is saying. But we want to do both of them. And how we would do that just all in one go is we would write this density. So we would write 0.001 and then grams per centimeter cubed. Cool. So it's going to look like that, and you can kind of put it into parentheses if you want. But at the end of the day, we want to convert this to grams per meter cubed. This is what we're shooting for. So we don't have to change the grams part. That's cool, and it's upstairs, so sweet. But we do need to change this. So even though this is cubed, how I teach is just like, well, don't worry about the cubed yet. Just convert centimeters to meters. What do we know about centimeters and meters? Well, maybe I do know that there's 100 centimeters, in 1 meter. So I know that these kind of are equivalent, and a lot of textbooks will actually have you write, these as an equal. But I think this kind of gets confusing. I would just immediately get into the stack method. Just stack 100 centimeters on top of 1 meter, and like this is a kind of a true statement. It's just stacking those things, but both of these things are the same. So this is equivalent to just saying that multiplying by 1. And then you can also stack the opposite. You can put 1 meter upstairs and then 100 centimeters downstairs. So that's the two things you can do with factor label. And then cool. And then what you do is just multiply it up against here. So then you're going to get things to cancel. Centimeters cubed is downstairs. So we need centimeters to be downstairs. So we're going to use this one. Okay, so we're going to have 1 meter upstairs and 100 centimeters downstairs. But we have... How the hell did I just do that so wrong? So centimeters cubed is downstairs. We need to cancel it with something upstairs. So my bad on that. Holy Toledo. So we have 100 centimeters and then 1 meter. Sweet. So now these units can cancel, and then we're just left with this meters downstairs. But it's not cubed. I think the simplest way to do it is just, now throw a cube on it. But this is gonna get you into a world of pain if you don't know exactly what's going on. So we're gonna bring this over here. 100 centimeters, 1 meter. This is the part to really slow down on, and it's kind of a teachable method. Even though that these are units, it's still 100 parentheses, centimeters, parentheses, 1 parentheses, meters parentheses. These are all products. It's 100 times centimeters. It's 1 times meters. And then so when we go to cube it, we can cube each of these things. So let's do that. So we're going to have 100 cubed, centimeters cubed. This 1 gets cubed. This meters gets cubed. Okay, sweet. And if you have a number, this is going to be 100 times 3, and so or cubed. So that's going to be 100 times 100 times 100. And this is also a teachable moment. Like, hey, you're going to see this is 1, 2, 3, 4, 5, 6. Cool, that's going to be 1,000,000, so you could do it that way. You could say 100 is 10 to the 2 because you got 2 zeros, and then we're going to cube it. And then so if we do this, this is the equivalent of 10 to the exponent of 2 times 3. This is also 10 squared times 10 squared times 10 squared. We did it 3 times. Those are going to be equivalent. And this is also going to be 10 to the 2 plus 2 plus 2. So that's another way to do it. You get 10 to the 6. This is going to be 10 to the 2 times 3. That's 10 to the 6. So we just did 3 different methods to do 10 to the 6. I think that's where my videos are kind of cool, because this is the stuff that I wish people would have spent more time on and gone over, because I don't know, like, it took me a long time to figure out my own method, you know what I mean, that I liked when dealing with like cubes or squares and changing units. All right, hell yeah. So then when we do this, this is 0.001 grams per centimeter cubed, and now we're going to multiply it by, this is 10 to the 6, so we're going to have 10 to the 6 centimeters cubed. Divided, 1 cubed is just 1, so this is just going to be 1 meter cubed. You don't even have to do the 1 if you don't want to. And so now centimeters cubes cancel. We're left with meters, grams per meter. And then this, you could even change. This is, if we had 1, we're going to go 1, 2, 3. So this is 10 to the negative 3. So we got 10 to the negative 3 times 10 to the 6. So in essence, this is just going to be 1,000. So we're going to have 1,000 grams per meter cubed. And is that what we would expect? Well, we just said that air was 1 kilogram per meter cubed. Air is 1,000 grams. So yeah, so hell yeah. So this density, if you can make aerogel as light as air, 0.001 grams per cubic centimeter. And again, what we were doing was like, hey, what's if water is 1, what's 1/10? Maybe foam. What's 1/100th? Well, typically aerogel, but they're saying aerogel can be as light as air. I'd like to see that. But anyway, sweet. So now we have now this is a check on reality, that this density of aerogel is equivalent to 1,000 grams per cubic meter. So there you go. It's not 1 gram per meter. So this is glaringly wrong. These are totally wrong. Okay, so we did that one. So now let's do this one just a little bit faster. And I think a lot of people don't use scientific notation. So this is going to be, if this was 5, and then we move the decimal place to there, this is going to be 5 times 10 to the negative 1. And we're going to have grams per centimeters cubed. We're going to multiply it by, again, 10 centimeters per 1 meter. We're going to cube this. And so this value is going to be 10 to the 6, and I'm going to have meters cubed. The centimeters are going to cancel. So now let's see what we have here. We have, and then anytime you do a scientific, this x, that's tripped me up quite a bit, in the future. But now I do it like this: 5 times 10 to the negative 1. It's a product of 2 numbers. You can do anything you want with those. So now I can do 5. I can do 10 to the negative 1. And then I can multiply by 10 to the 6. Sweet. And then my units are grams per meter cubed. So now I can easily do 10 to the negative 1 times 10 to the 6. That's going to be 10 to the 5. And now I'm going to have 5 times 10 to the 5. So 5 times 10 to the 5 grams per meter cubed. And what's 10 to the 5? That's going to be 5 zeros. So we're going to have 5, 1, 2, 3, 4, 5. And hell yeah, this is how many grams are going to be in 1 meter cubed. Maybe I don't know what grams are, so I'm going to, move the decimal place by 3. This is 500 kilograms in 1 meter cubed. You know what I mean? So now I have 500 kilograms. There's going to be about 2 pounds per one of these kilograms, so I have about 1,000 pounds. Cool. Didn't we say a meter of water was 2,000 pounds, basically a metric ton? And now I have 1,000 pounds of this aerogel because they made it real bad and it was actually pretty heavy. You know what I mean? It's almost like wood. Wood can have a density that's half of water. That's what they're saying here. This is half of water. And maybe this statement is true. Maybe there's no such thing as aerogel that's like very heavy at all. You know what I mean? So this video is just showing you that AI sometimes is just a nightmare when you're trying to look up facts about reality, and they just get it totally glaringly wrong, especially when they do stuff like this, where they have two different numbers. They say this is the density per cubic centimeter, and then they just go on to say if you had a cubic meter of it, this is the weight, and it's just, it's wrong. You know what I mean? And so, oh, you know what? I found their error. Because this is 1,000 grams per meter, and this is 500,000 grams per meter. This is 1 kilogram per meter cubed, and this is 500 kilograms per meter cubed. So there we go. We have 500 kilograms. This is 1 kilogram. So there you go. This is the only thing that's wrong. Instead of grams, this has to be kilograms. So it would weigh between 1 and 500 kilograms. But I don't know where these errors come. You know, I'm just saying that if you replace grams with kilograms, then you get the right answer. But yeah, it's just fascinating. This AI, I've seen this a lot, where they'll just get numbers wrong, and it's kind of fun to. Well, it's awful if you're just trying to find legitimate information, but it comes up so much that it's kind of fun to see why they get it wrong. Alright, hell yeah, so that was factor label method, but more importantly, this first problem physics stuff says like, hey, you know what I mean, can you just guess? Like water, it's density of 1. Like, what's air? I mean, do you think air is just 10 times less than water, 100 times less than water, or 1,000, or 10,000? So somewhere, or 1,000,000, you know what I mean? Like, I don't know. I bet you if you ask people on the street how much does air weigh, and you said 1,000 times less than water or 1,000,000 times less than water, I think a lot of people, like me, I would gravitate towards the 1,000,000. I think it's impressive that air is kind of like clunky. You know what I mean? It's heavier than I thought, and it was just fascinating. Never in my life did I understand. You know, it was only until figuring out what things were in these categories that helium and hydrogen are 10 times less dense than air. So that was pretty cool. So that's going to be 10,000 times less dense than water, and air is 1,000 times less dense. Alright, so sweet. So we're going to be continuing on with more first chapter physics problems, and we got one on density. So hell yeah, thanks for joining me on this one, and guess what? That's a video.